Hello everyone, this is 7.3 part 2, and we're going to look at example 2, which is the integral of 1 over the square root of 4 plus x squared dx, where the dx is actually on the top. Alright, when we see that square root of 4 plus x squared, the plus, if you might remember from part 1, reminds you of the t in tangent, so that's just a little mnemonic to help you remember what kind of trig function you want to use for these trig substitutions. So let's go ahead and use tangent. So we're going to let x equal the square root of 4, which is 2 tangent theta. Our dx will be 2 secant squared theta d theta. Remember, the derivative of tangent theta is secant squared theta. And the restriction we're going to use for tangent is between negative pi over 2 and pi over 2. That'll make tangent 1 to 1. Alright, we'll go ahead and switch to blue. And on the bottom, we're going to have the square root of 4 plus 2 tan theta squared. Now the dx is going to become 2 secant squared theta. We'll just stick the d theta over to the right, just to make it look nice. Now the whole thing about doing the trig substitution again was to collapse the radical. Let's do that work off to the side. We have the square root of 4 plus, and then 2 tangent squared, 2 tangent quantity squared becomes 4 tangent squared theta. We can factor out the 4. That was the whole reason we chose 2, so that when it got squared, it became 4. So now we can pull out that 4, and we have 1 plus tan squared theta. And using a trig identity, the Pythagorean identity, we have that 1 plus tangent squared theta is equal to secant squared theta. That's one of your trig identities that you get from the basic one, sine squared theta plus cosine squared theta equals 1. Now, because of the restriction that we chose, we can write that the square root of 4 times secant squared theta is just 2 secant theta, because the absolute value of secant theta ends up just being secant theta if secant theta is positive, like it is in the first and the fourth quadrants, which is where theta is in. Alright, so now that we've collapsed the radical, we have 2 secant squared theta over 2 secant theta d theta, and some cancellation can happen here. I'll break out the red pen, so we got the 2's canceling, we have one of the secants canceling, so we just have one of them left. The integral of secant theta d theta. And the integral of secant theta d theta is one that takes a trick to figure out how to integrate. I think I mentioned that I would give this integral to you on tests, and that I will do. So it's the ln of the absolute value of secant theta plus tangent theta plus c. It comes up here and there, so it's a good one to just commit to memory if you can. Alright, so then we want to go back from theta into x. That's the last part of it. We want to go back to the variable we started with. Now we can solve for tangent theta. That's x over 2. So we know what to replace tangent theta with. But we also need to replace secant theta with something, and so we need a triangle. So let's go ahead and make that triangle. The triangle that has angle theta in it. So we'll just start with the tangent theta is x over 2, Again, we get that from solving the original substitution that we set up for tangent theta. Just divide the 2 over. And then we can make a triangle with an angle theta in it, so that the opposite side is x, the adjacent side is 2, so that tangent theta equals x over 2. And then the hypotenuse we can get using the Pythagorean theorem. So in this case, we'll get square root of 4 plus x squared, or square root of x squared plus 4. Notice that this side right here that we got is the same as this original radical that we had. That happens all the time with these trig substitutions. So now that we have our triangle set up, we can get things like secant theta. Let's see, secant theta, I always think of it as the reciprocal of cosine. So if cosine is adjacent over hypotenuse, secant will be hypotenuse over adjacent. So it'll be the square root of 4 plus x squared over 2. Then we have tangent theta, which is just x over 2. Close the absolute value bar, put the plus c, and we are done with example 2. To be continued in part 3. Thank you for watching.